Okay, this is the segment links and circles packet. And so we are going to use two different formulas, if you will, today. So if we're dealing with secants and or tangents, these things will intersect outside the circle. I mean, if they're secants and they intersect inside the circle, we can just consider them chords. So if there's secants and tangents intersecting outside the circle, we're going to use this formula of ow. Outside times whole equals outside times whole. So outside times whole. Okay. So as we look at this, let's look at the secant for starting. This is the secant, and the 9 is the exterior portion of that secant. We're going to call that the outside portion. So this is going to be 9 times the whole portion. So what's the whole portion of the secant? Well, of course, yeah. I definitely think that my video processor's got a little more than it can handle. Doing recording and everything. Give me a second. I'll see if I can get that to all go away. All right, so the whole portion of this is going to be the 9 plus x. So the outside times whole is going to be 9 plus x. Let's see if I can get that to come back. Yeah, I think she's gone forever. So there we go. Perfect. So 9 plus x. Now, the outside of the tangent, this is going to be your tangent in green because it only hits once, is equal to 15. And the whole is also equal to 15. All right, so now let's multiply this. And I'm going to distribute here, and I'm going to get 81 plus 9x equals 225. Subtracting 81 from both sides, I'm going to get 9x equals 144. Dividing by 9, I'm going to get x equals 16, and I'm done. These don't take that much work. Later, I mean, everything that's new, everything that is geometry is located inside this formula, ow equals ow. So ow. And identifying what these shapes are, secants and tangents. All of this from here down, that's all just algebra. And you guys have already had that class. All right, we're going to move on. The next problem I'm going to do is number 3. And so we're going to once again, because these are both secants, I'm going to use ow. So outside times whole equals outside times whole. So the outside of the upper secant is equal to 4. And the whole upper secant is going to be 4 plus x minus 3. So that's going to be 4 plus x minus 3. And the outside of the lower secant, this part here, is going to be equal to 5. And then the whole lower secant is going to be 5 plus the other section of this, which is x minus 6. I know that half of this erased, but I believe I've got 4 and a minus 3 here. Right, so that's going to be 4 times x plus 1 when I put those two together. And this is going to be 5 times x minus 1 when I put those together. And then as I distribute, I'm going to get 4x plus 4 equals 5x minus 5. And I'm going to subtract 4x from both sides and add 5 to both sides. I'm going to get 9 equals x. Easy cheesy. Number 5. So on number 5, I'm going to use a different formula now because this is 2 chords. 2 chords crossing inside of a circle. These 2 chords cross right here, and they have portions. So I want to look at the portions of one side, so I'll call these A and B. And the portions of the other side, let's call this C and D. And those are going to be multiplied together to equal each other. So what I'm looking for is A times B equals C times D. So let's go through and plug that in. Well, A is going to be 4x plus 2. B is going to be 8. C is going to be 9. And D is going to be 4x. Multiplying this out, I can distribute the 8 to the 4x and the 2, and I get that 32x plus 16 equals 36x. I can subtract the 32x from both sides, and I get 16 equals 4x divided by 4, x equals 14. Done. So number 7 appears to be a pretty simple problem. It looks about as easy as number 4, say. I wouldn't see much difference in it, except for the location of the x, which is what's going to make the difference. So if we go back to our ow equals ow, outside times whole equals outside times whole. So let's start with the tangent because it's easy. I get 36, right? That's going to be outside is 6, the whole thing is 6, so multiply those together and I get 36. Why waste time, right? So the other one, though, outside is x, and the whole is x plus 5. So I got to add those together, x plus 5. Now we start to see where this is going to go wrong. When I distribute this, I'm going to get 36 equals x squared plus 5x. Now, stop copying me at this point. And let me show you, because I know a lot of you are saying, well, Mr. Conaway, there's a square. You take the square root. So let's try that idea out. I guess what you mean by that is let's subtract 5x from both sides. And let's see if I can get x squared equals 36 minus 5x. And then if I square root both sides, I'm going to get x equals the root of, well, positive or negative root of 36 minus 5x. Now the question is x alone? Can I define x in terms of another x? Can I say that an object that is circular is shaped like a circle? Can I say circles are round? Round things are circular. No, because I'm defining something in terms of itself. I cannot use something to define itself. And therefore, this is not really solved if another x is on the other side. I have not actually solved it. So I need to not think this way. And let's go back and look at how to do this the right way. So let's solve this by making a trinomial. I'm going to subtract 36 from both sides. And I'm also going to do a big flip-flop. We can always switch sides of an equation because equations are symmetric. They go both ways. So x squared plus 5x minus the 36 that we had right here equals, well, these two are going to go away and be 0. So now I have a nice trinomial. And we learned back in Algebra 1 that to deal with a trinomial, we're going to factor that trinomial. So we're going to say, well, x and x obviously go here because x times x equals x squared. But now I need things that multiply to give me a negative 36. But when I combine them using addition or subtraction, they come up with a 5. So what multiplies to be 36? Well, 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Which of those could I add or subtract to be 5? Yeah, so 4 and 9 is my class is trying to tell me here. So 4 and 9. But in order to get a negative on that 36, one of these has to be negative. So yeah, if we, and my class once again says negative 4, positive 9, then when I add these, I take a positive 9x and a negative 4x, and together they do make a positive 5x. So yes, I'm good. I've got this done. But just in case, I can check it out. X times x is x squared. X times 9 is 9x. Minus 4 times x is minus 4x. So 9x minus 4x is 5x. We got that. And then minus 4 times 9 is minus 36. We've got that. So this definitely works. Now for the next step. And some of your teachers may not explain why you're allowed to do this step. But we're going to split these two and say x minus 4 equals 0 or x plus 9 equals 0. And the reason we can do that is because If I told you that 3 times blank equals 0, and blank times 5 equals 0, and A times B equals 0, you could quickly see that 0 has to be involved. So one of these two have to be a 0 to get the B. And therefore, I can write this statement that x minus 4 equals 0 or x plus 9 equals 0. And I'm going to solve it and get x equals 4 or x equals negative 9. Now, one of these is right, one of them is not right. Since this is geometry, we cannot have a negative length. So therefore, x equals 9 would not be a possibility we would consider. And x equals 4 is the correct answer. Done.